Alright, Math 2, Practice 6.1.3, Properties of Tangents of a Circle. So remember, a tangent hits a circle at one point. That was a horrible tangent, but you get the gist. So it doesn't go through, that's a secant, and if it doesn't go out of the circle, that's a chord. Okay? So it says AB and AC are both tangent to circle D. So we've got circle D here. So we've got point A, and then C and B. So it's from the same point, and it's going to, and it's tangent from that circle. Okay, so what we know about that is that these two line segments, AB and AC, are going to be equal. So we know AB is 14, and AC is that x minus 3. So I simply go 14 equals x minus 3, and then we solve for x. Add 3, we get 17 equals x. That's what it wanted to do on us to do on that one. Okay. The other thing we know about a tangent is that when we have the radius, that tangent line is going to meet it at a 90-degree angle. So if we're asking if something is tangent, we're going to check, is that a 90-degree angle? So that would mean this would be our hypotenuse, then our two legs, A and B, and we use the Pythagorean theorem to double check that. So I'd go 9 squared plus 40 squared equals 41 squared. So 41 squared is 1681, 40 squared is 1600, 9 squared is 81, add that side, and we get that they are equal to each other, which means yes, that's a right triangle. So yes, this is a right angle, which means yes, because that's that 90-degree angle. They're perpendicular to each other. The radius and the tangent means that AG is a tangent. Alright, question 3 says, QR is tangent to circle S at point R. What is the length of QR? So we know that this is a right angle because they told us this was tangent, that QR was tangent. So now we can use the Pythagorean theorem the opposite way to figure it out. So we'd have A, B, and C. So I go A squared plus 12 squared for B equals 37 squared for C. A squared stays the same. 12 squared is 144. 37 squared is, now we'll need to grab a calculator for this one. So 37 squared gives us 1,369. So we subtract 144 from that, and we get 1225 equals A squared. So then we take the square root of that, and we come up with A, which is what QR was. And that is equal to 35. So that length is 35. Alright, question 4. It says the class pet is a hamster. It has an exercise wheel like the one pictured below. What is the length of the base of the wheel stand? Okay, so if we look at this, we should realize that this is going to be a tangent here. Okay, so that means these are 90-degree angles. Okay, we know this length is 5. We know that these two are both going to be 8. Okay, so it means these are going to be the same side length. So if we just double whatever we get for this side length, that's going to give us everything. So once again, we use the Pythagorean theorem. So that's my C. So 8 squared equals 5 squared plus something else squared. So 64 equals 25 plus something else. Subtract by 25. And we get 949. No, 39. Equals our question mark squared. We take the square root of that, and 39 is not going to give us a nice neat number, but that's alright. So 39, take the square root of that, it's about 6.2449, so we'll say 6.245. Okay, now we double that to get that full length. Okay, So the length of the base equals about 12.49 centimeters. So now looking at 5, it says BC is tangent to point A. So we should know right off the bat that's a 90-degree angle. What is the length of BC? So once again, Pythagorean theorem it up. And we go 20 squared plus A squared equals 9 squared. So we get 81. Oh crap. I almost made a mistake there, didn't I? That 9 actually only stands for that piece. The radius is 20, so that radius would be 20. So that whole length is actually 29. So it really should be 20 squared plus A squared equals 29 squared. That's really where we should be at that. So 29 squared is 841 equals A squared. 20 squared is 400. Subtract 400 from both sides. You get A squared equals 441. Take the square root of that, and side A would equal 21. So that's our length right there. Alright, moving right along. So number 6 says Emma must prove that AB is tangent to circle C at point A. So circle C, point A, we want to know is AB tangent to circle C. She's going to show that a triangle ABC is a right triangle. Why is this an important part of her proof? So if I made a triangle out of that, it says she has to prove that that's a right triangle. Well, because the rule is that a tangent is perpendicular to the radius. So if that's a right triangle, right, then we know that that's a 90-degree angle, and we know it's tangent. So that's why it's such an important piece. Alright, number 7 says, the sides of quadrilateral PQRS are tangent to the circle of the points as pictured below. What is the length of QR? So the idea here is, since they're sharing a point here, those are congruent, so that's going to be 8. Those two are congruent, so that would be 2. So PQ would be 10. Those are congruent, so that would be 5. So this side would be 7. This side would be 8. And so this side would be congruent to this side, so that would be 3. So we'd get 11. So QR is 11. Looking at number 8, it says pictured below is the logo for the, I think we have better here. Here we go. Pictured below is the logo for a new ice cream shop. The circles are congruent. If the diameter of each circle is 10 feet, so that's 10 feet, 10 feet, will the logo fit on a billboard that is 60 feet tall? So in other words, if we have this billboard here that's 60 feet tall, will it be big enough to fit? So you can think of this space as being 10 feet, right? Then you'd want to say, oh, well, that's, looking at it, but you can't. We've got to figure things out, okay? So what we can do here is we know that these, how do we know that they're going to be congruent? Okay, I don't know if we can assume that. I want to say because these circles are going to be congruent, that most likely they are. However, I'm not so sure we can actually say that at this point. What we can probably assume, okay, is the center of the circle out here would be 5 feet, right? So from here, the center to here, that would be 5 feet right there. Okay. Here's what we can do. Can we assume that that's tangent and that's tangent right there? So these two sides would actually be congruent. And since this is tangent here and here, that all three of those would be congruent. So if we find their size, so if I go 3x plus 18 equals 5x, subtract by 3x, get 18 equals 2x, divide by 2, we get 9 equals x. So 9 would equal x, so that would be 45, which means this would also be 45 from this tangent point down to here. Then the rest of that radius would add another 5 feet, so total we'd have 45 plus 5, which would be 50 feet. So with some space above and below, yeah, it could. And all that work that I just did is explaining how it would be that way. Alright? Alright, number 9. A satellite S is in orbit around Earth, is sending two signals that are tangent to Earth at points A and B. If arc ACB, so that's a major arc, right here, is 208 degrees, and arc AB, so that's a minor arc, is 152 degrees, what is the measure of angle S? Okay, so now we have a connection here. Okay, the way this works for that angle S, X, it is 1/2 this guy, this arc length 208, minus the smaller arc length 152, and then times by 1/2. So we go 208 minus 152. That gives us 56. We cut that in half, so divide by 2 or times by 1/2. Same thing. And that gives us 28, so this would be 28 degrees. Okay, and that's just one of the rules, right? That is equal to 1/2 the larger arc, ECB, minus AB. Alright? Okay, number 10. Students in an algebra class are designing a new banner. That was number 9, right? Yep. A new banner for the school's mascot, the fighting duck. The beak is made from two tangents connected by a vertical line at the point of tangency. If the students have only 200 feet of material for the duck's beak, what value of x will make the tangent sides the correct length? What is the length of each side? So, I think that's a poorly drawn picture because it doesn't look like it's a tangent. It actually looks more like a secant, but we'll pretend that they're tangents. So I know, because they're both tangent from the same point, that they're equal to each other. Okay, so it would be 8x plus 8x, so we'd have 16x. 16x, okay. Now, it has to be, they only have 200 feet of material for the duck's beak. Okay, so what value of x will make the tangent sides the correct length? Now, my question is, do they have to do the area or just the lengths? Let's treat it both ways. Okay, so we know that 16x has to be less than or equal to 200. So if we divide by 16, we get x is less than or equal to whatever 200 divided by 16 is, which is about 12.5. Okay, so x has to be less than 12.5, so the side length, if we go 8 times 12.5, has to be less than 100. Okay, which would make sense, right? So the side length. Now, that's only just for those lengths right there. Okay, so I almost feel like this is probably more of an area problem since it's a banner. So if we drop this down at a 90-degree angle here, we could, that would definitely split it in half, so we'd have 8 here and 8 there. And in this, it would depend on how big we'd want to make it. But if we think about the area of a triangle, it's the base times the height. Okay, 1/2 times the base times the height. So this h would be our height, and this would be our base. But honestly, because there's two of them, we would double that. So it's really just base times height, which would have to fit into 200 feet of material, which means we'd have to connect some things because we need to figure out what length these could be in order for that to work. And since we don't know, maybe they don't want us to do. But we know it would have to be less than 100. That wouldn't work the same though, because of how it's set up the problem. This is kind of I don't like this problem so much because it doesn't give us enough information. So let's say the length of each side has to be less than 100. It can be the maximum 100, but it has to be less feet. But that obviously would only give the 200 feet for that. So if we have the 16 feet from that, we'd probably want to subtract 200 by 16, wouldn't we? Then we'd divide by 16. So x would actually be 11.5. So these would actually be 92. So the length of each side would be 92 if we're including that 16 feet for just the outline. Okay, and if we want to find the area of it, which I don't think will make that a problem. So x would have to be 11.5. Length would be 92 feet. And then that would be way too big to probably fit with the 200. We'd have to make it a lot smaller to make it work for that area. So I think we'll call that good right there. And that's pretty much our last question. So yeah, let's go with that.